Before you get started, the first thing that you need to do is get the Git installed. Now, unlike other tools, as I said, you do not have a separate server and a client. So all you have to do is install one small application or a software called as Git client, and that will help you to start working, where using that, you will be creating workspace, you will be trying to do the changes, you will be trying to do the commit, and you will be trying to sharing it between the central workspace and the local workspace. So all those things you will be doing using one tool. So if you want to work on Git, all you have to do is on your machine, make sure that you have installed the client of Git. So there is nothing called as a separate installation for server. There is only one installation that we call it as a Git client. Okay. So how is that you're going to install? Now, if you go to the Git download sites, or if you go to the Git site, you have different types of executables based on the operating system. Okay, so all you have to do is, whether it could be a Windows machine or it could be a Linux machine, or if you are having a Mac, then you can just go ahead and click. This will try to download the specific executable. Once you download it, just run it. Okay, so there is no difference. And pretty much now, whenever we are going to work, there is again no difference on how you are going to install, but we are going to use completely from the command line way. So that is how, whether you are installing it on a Linux machine or a Windows, for practicing, it is not going to make any difference. But the only difference that is going to make in your production is, if you're trying to install it on Windows, then there might be certain performance issues, because we know the Linux fundamentals is, on a Windows machine, you cannot access multiple users at the same time. Whereas in Unix, you can access the machine or a software at any point of time as a multi-users. So we have certain limitations that way. So that is when in organization, when you go for production, they will be using Linux machines. But pretty much for our practicals or for your practice, you can install it on Windows also, because it is the same command, whatever that you're going to use in Windows will be used again on Linux. So there is no difference in the concept or the workflow. Okay, the only difference is where you're installing it. So that way, even in my case, I'm going to install it on Windows, and we are going to work on using the Git command lines. Okay, but in Windows, if you're installing Git, you will have an additional feature where as soon as you install Git, after you download a specific executable that you get here, if you go, you will be getting an option like this, where in that you will have two command lines options that you can use. One is git cmd, the other one is git bash. Now, the advantage of using this git bash is, as you know that, in case for those who doesn't know what is the bash, I would suggest to go through the Linux essentials so that you will get an understanding on what bash is. But again, to just quickly give an introduction, a bash is nothing but an environment using which you will be working on any Linux machine. So what is that Git is doing here? So if you are installing Git on Windows, additionally, it is going to give you a command prompt where you can have a bash-like environment in this. So look at this. This is not a Windows command prompt. Okay, this is my Windows command prompt, whereas this is a bash command prompt which is coming by the Git. And the advantage here is, if you want to work on the basic Linux commands, you can use it on the git bash command prompt, whereas you cannot run it on the command prompt given by Windows. For example, if I want to type in some basic commands, that is Linux commands, this will not work on Windows. But instead of installing everything as an operating system, you can try to install the git bash which comes along with the git download. Now, I can use it on Windows and run all the basic Linux commands, so that I am going to have a feel of running the Git as if I am running on a Linux machine. So without installing Git on a Linux machine, by installing Git on Windows and using this git bash, I can pretty much run all the Git commands, and I can also run all the basic Linux commands. So pretty much in my class, I'm going to use completely this command prompt that is git bash. The reason behind that is certain operations like creating a file, deleting a file, or moving or editing a file will be very easy in this bash command prompt because we have a lot of Linux commands which can help us to do those activity easily, just like how you're going to do in the production. Because in Windows, if you have to create a file, first you will say right click and create a notepad, or if you want to edit a file, you will use an editor. Those kind of things has to happen. But since we are going to focus completely on the command line way, I'm going to use this bash command prompt given by Git, which is going to help me to have a complete Linux environment with all the basic commands of Linux will be working on this. Okay, so that's the advantage where I'm going to make use of this git bash on Windows. So I'm going to have all the basic Linux features that I want to run from Windows. I can get it using this. So I can use this to run some Linux commands. It is not that I have to use it only for running some git commands. You can run it treating similar to a bash environment, how you would have been connected to a Linux operating system. Okay. So the first thing that we have to do is, once you have installed, we have to do certain configuration. So what are the configurations that we have to do? Now, before doing it, one thing what you need to understand is, going forward, if you want to invoke Git, you will always be calling a command or a executable called Git. So through which we will be able to perform all the operations. So that is when, to make sure that you have installed Git properly, just run git ---- version. That should give you the result of what version of Git that you have installed and you're using. So that way, now any command that I'm going to run will first invoke the git executable, and followed by that whatever command that I'm going to use. And it is going to be a straightforward way where the name will be quite easy in the operation what it is going to do. So for example, if I'm trying to do the configuration, then we will be using a command called git config, where config is a short name given for configuration. Okay, so that way the command will be directly giving us the indication on what is the purpose, and any option that you're going to pass to this command has to be followed by a double hyphen. So a double hyphen represents you are passing a value to the command. Okay, so the first command that we are going to invoke is git config, where using the git config we are trying to do some configuration through which if we run the git, it will be running based on what configuration that we have given. So when you're working on Git, there are primarily three major configurations that we have to do. Okay, so there are a couple of others, but they are not mandatory. Depending on the use case you can set, but in order to work or to get started, the primary requirement is you need to have three configurations. So what are those? So you need to tell on what is the name of the user on which you are working, then what is the email of the person as whom you are working. That is because when you are working in an organization, you will be given a specific user ID, so that whenever you do a commit, it will be taking that user ID or the login name and create the commit ID, so that if anyone wants to know, they can easily know that, hey, okay, this is the commit ID which corresponds to a person working in an organization, so that they can get back to you if needed. Okay, so that is why you're going to give the username as whom you're trying to work, and then you're going to give your company's respective email ID, so that if someone wants to reach you by looking at the commit ID for some purpose, they can know that, okay, when I say a commit ID, it will give me the complete details about who modified, and it will also give me the email ID, so that I can get in touch with him saying that, hey, I have some doubts, can you help me in understanding, or if there's a problem, you can get in touch with that person. And then the next configuration what we have to do is something called as push.default. Okay, now what exactly it is and why do we need, I'll explain it later when we go through a different concept, but for now just remember that you need to set a value called push.default as mandatory. So let's try to set this one by one. So first I'm going to set the value. Now if you look here, I'm going to set the username, but in addition to this, I have actually passed a argument called global. So what is the necessity of this? So now on this machine where I'm going to use Git, I can create more than one workspace and work. And every workspace will have its own repository. That is also we saw. So now, if you want to have different configurations on each of the workspace, then you can set it locally. If not, the standard what we are going to do is use an option called global, so that I am going to set it only once, and no matter how many workspace I am working on this machine, I will be always using the same data. So that is why we are going to give it as a global, so that I don't have to keep doing the configuration again and again for every workspace that I'm going to create and work. Okay, so that is the option. The next thing what you're going to do is the user email. And in this, as I said, you will be giving your companies. Now, for your testing, it doesn't matter what you're giving because it's just a reference. Okay, so once you have done, the third thing what you're going to do is push.default. And the value for this, you're going to keep it as simple. And once you have set, at any point of time, if you want to know what and all are the configurations that you have set for Git in this machine, then simply say git config and list. So it is going to give you all the configuration that it has been using. And as I said, these three are the mandatory one that we have set. And pretty much other than that, we have a couple of others like what is the color of the screen or width, and those kind of things is not important for us. So that's how the most important things are these three. So once you have done this thing, we are pretty much ready to work on Git on this machine using this Git bash. Okay. So to get started, what is that we have to do? Now, in Git, everything is a workspace, and then every workspace is a repository. So that is when, as a best practice, now, if you want to create something, first, let's create the central workspace, because you will always create the central workspace, and with respect to that, you will be allowing the users to do some change, right? I'll talk about it, Mujahid. As I said, in order to understand what is that push.simple, we'll first have to understand the workflow, and then I will try to talk about what exactly that push.default does. Okay, so that's what I'm trying to do first. So before that, first we have to create the workspace or the repository. Now, when I refer to workspace or repository, it is one and the same because both of them are present in the same directory. So when you actually go to a company and you want to work, you will create a workspace that will be your user workspace, but you cannot always create from scratch. So you will be actually taking a copy of something which is existing, and top of that you are going to do some changes. So that way, now if you want to create a copy of a workspace, you will be taking a copy of the central workspace only, because this is going to act as a common workspace where everyone will store their changes. So as a practice, the first thing what we will do is we will create the central workspace first. And note it down, it is only a one-time activity when you are creating a new repository for a product. You will not be doing this always. Okay, so the first thing what we will do is we will create a central workspace or a central repository, and from that we will create a local workspace or a user workspace. Okay, so to create a repository or to create a workspace, so that's when I said a repository or a workspace, both are going to be pointing to the same thing. So in Git, we have actually two types of repositories. So what are the two types of repositories that we have in Git? So one is called as a bare repository, and the other one is called as a non-bare repository. What is the difference between a bare repository and a non-bare repository? So to understand it, first, let us go back to the same diagram what I was trying to show you here. And now, here if you see, this is the bare repository. Okay, so this is the bare repository. And now, if you see, this is the non-bare repository. So This is also a workspace. This is also a workspace. But the difference is this is a central workspace, whereas this is a local workspace. And if you look at this, I have clearly mentioned that a central workspace is a workspace where you are going to use it only for storing and sharing. You cannot do any modification in this, right? As well as the user workspace or the local workspace, you can store and share, but top of that, you can do the modification. So that is how, if you are creating a repository which is going to be treated as a central workspace, then we call it as a bare repository. So a bare repository simply means you are using it only for storing and sharing. Okay, so where will that be present? So pretty much a bare repository will be present inside your central workspace, or a central repository is what we refer as a bare repository. And this is going to be acting as a central workspace or a repository which will be used by different people to create their workspace. And remember, you cannot do any changes in it directly. And what is the non-bare repository? So if you go back, non-bare repositories are the user repositories or the user workspace, and inside the user workspace you are going to have a repository, right? So that repository where a user can modify the change and store the change is what we call it as a non-bare. Simply, all the user workspaces or the local workspaces which is used by users will be of the type non-bare. Okay, so that's the simple thing that you have to think, that every user who creates his workspace will be of the type non-bare because he can do the modification in it as well as store the change. Whereas if you go to the central repository, it is used purely for storing and sharing. You cannot do any changes in it directly. Hence, it is going to be acting as a bare repository. All right. So in order to set up our infrastructure or to set up the project, the first thing what we will do is we will create a bare repository, and from that bare repository we will try to create our workspace, do the changes, and then put the changes back to the central repository, and we will try to work on in multiple user concepts. Okay, so the first thing that we have to do is create a bare repository. So for doing it, you will be using a command called init, which represents that you are initializing a repository, and for that you will be passing an option called bare, so that the repository that you are creating should be of the type bare. If you do not pass, then it will be creating a non-bare repository. So as a standard, we are not interested in it because we are first going to create the central repository of the type bare, and from that we will allow the users to create a copy and not create a new repository, but a copy of that repository. Okay, so this is what the first thing that we are going to do. So before that, what I'm going to do now is I'm going to create a folder in my machine. Okay, so this is just a folder that I'm creating it for my reference, because all the Git related workspace I'm going to store inside this directory, so that any point of time if I want to view something, I know that it is going to be present inside my directory called cvisva git. So pretty much if you see, it is a Windows machine which I'm accessing through the Git bash. So if you go to your C drive, okay, so you will have the Git. So this is the same thing what I'm trying to access it here. Okay, in this, now when you're trying to create a central repository, first thing is you have to create a directory for it. And while creating a directory, now you can use any naming convention, but for our simplification on understanding, I'm going to name it as central, so that we know that it is a central repository or a directory. But make sure when you are trying to create a directory which is used for the central repository purpose, then always end the name of the directory with .git. So that is how, if you look at a directory, you can know that if it is ending with .git, then it is not a normal directory, but it is a central directory, or it is a bare type repository is what we will be easily knowing. So how can you simply differentiate between a bare repository and a non-bare repository is by the naming convention. So all the workspaces which is going to have a bare repository will end with the name .git, and all the user workspaces will not have any .git. Okay. So once you have created your folder which is going to be acting as our central repository, now inside this you will run the command called git init bare. Okay, so now you can see that it is saying that it is going to initialize, or pretty much it has initialized a empty repository inside this directory. So going forward, this directory is what going to be acting as our central repository of the type bare, and I cannot do any changes in it directly. I can use it only for storing and sharing. Now let's come out of it. So on this Git directory, I'm just storing all these things. Okay, so now all the other workspaces that I'm going to create, I'll be putting here itself. Whereas in your production, you can have the central repository in some other directory or some other machine, and you can create your local workspace in some other machine. So it is not dependent. Now, how is that you are going to create a user workspace? Because now I am not supposed to do anything on this directly, right? So as a user, if you're trying to work for every product, there will be one central repository. From that, you will create your copy of the local workspace. So that way, in order to create a local repository or a non-bare repository, you will use the command called git clone. And for this, you will give the option of what is the name of the central repository or the remote repository. Once again, another name what we are going to use for a central repository is remote repository. The reason behind that is, in production or in your organization, you will not be keeping everything in one directory. For our example, when you practice, we are going to do it. But in organization, your machine is separate, and where you are going to keep all the central repository will be in some other machine. That is why we are going to call it as a remote repository. Okay. So the first thing that you will say is your remote repository name and what is the name of your local workspace or the repository which you are going to create a copy based on the central repository. Okay. So that way, now first remember to come out of it, not to run anything inside, because if you do anything inside, it is going to give you an error. So you have to come back to some other directory or to the parent directory and then run git clone, and I will say the central repository. So when I'm saying central repository, you have to always give the complete path so that the Git can access this. So when I say complete path, in Linux or Windows, we have two kinds of reference to a directory. One is absolute, the other one is relative. So absolute means you will always refer to that directory from the beginning. If not, you can always refer it from the current directory. So once again, for those who doesn't understand the difference, please go through the Linux essentials what we have shared, and you will get the clarification on what I'm trying to say. So now, the two ways of referring this is either I can say it like this, okay, or I can also say git clone central. The difference is we are already inside this directory, so I don't have to specify the complete path. So this way of referring is what we call it as relative. But let's say you are running this command from some other directory, then it won't know exactly where is this. So you have to give the complete path. So depending on where your central repository is located, you have to use the path. If it is on some other machine, then you will be using the complete location on that machine to use it. That we will see it later, but for now let's understand on how to create the workspace. So this is the central workspace from which I want to create a copy, and what is the name of the workspace that I want to create is what I'm going to give here. So what Git is going to do is, as the name says clone, it is going to create a copy of this workspace into this workspace, and inside it you have a repository, right? That is also going to get copied as a replica into this. Okay, so that is what we are going to do. it shouldn't be taking longer time, but it's just that some problem with my machine. But if not, if you look, actually, this is an empty repository. So now, if you go inside this, you can see that this is also a empty repository because you are trying to create a copy or a clone of this empty repository. So now you have one more workspace and there is no .git. It represents that you are trying to work on a non-bare repository. And inside a non-bare repository, I can basically do the changes and see the changes and store it. So right now, you can see there is no content in it. So here, you can see the same thing. I have a new workspace created and there is nothing inside it. Okay. So what is that we did? Now we created a clone of a workspace so that we have our local workspace, and in that we are going to do the changes. Okay. And remember, you are going to have the repository inside this also. Okay. So the first thing what we will do is, let's do some change or create a file and store it, because as of now we do not have anything in it. Okay. So to get started, the first thing that we will do is we will try to create a file. So I'll simply use a Unix command or a Linux command called touch to create a file. Okay. So what touch will do, it will just create a dummy file. And this is the reason why I am using a git bash. If I'm doing all those things on a Windows command prompt, I'll not be able to run this command. So basically, I have to go inside this directory and then right click and create a file. So instead of doing all those things, I'm just trying to make use of the git bash to run the Linux commands to simplify our task. Okay. So we have a file created. Okay. Now, if you run the command called git status, it is going to clearly say that this file is not tracked. It is because, going back to the basics that we saw some time back, any file that you are trying to create freshly, there is no data or details about it inside the repository. Now, let me take this diagram once again. So in this, if you look, we do not have anything in it, right? Same way, I do not have anything inside my repository also. So this is the current status of our workspace. There is nothing. In this, I'm just trying to create a new file called one.java. Now, does it have any information about it in the repository? Nothing. That is why the file is being called as untracked file, which means there is no previous information about this file in the repository. Okay. So once you have created the file, now I am interested in storing this into the repository. That is what as a user you want to do. So if you want to do that, now once again, in the basics we saw, I cannot directly take the file and put into the repository. So I have to go through the staging area and only then I have to do the commit. So how is that you are going to put the file from your working directory in which you are modifying the file to the staging area? So that is when we will use a command called git add. Okay, where git add will take all the files that you have modified in your current directory and it will put into the staging area. Okay. So now either you can give a specific file name if you are interested to take only one file, or if you simply say dot, it is going to take all the files that you have modified in your working directory to the repository. Because in Linux or Unix, git means current directory. So actually you are inside the workspace. So in this, if you have modified many files, if you just say dot, it will try to take all the files in the working directory and put into the staging area. So pretty much now, what is that we are going to do? We are going to put this and create a snapshot of it. Okay. So if I run and if you do a git status, you can see the file is not called as untracked, whereas it is being called as staged, or it is ready to commit. That means you have staged the file and taken the snapshot. Okay, so that is what we have pretty much done now. So we have taken the changes and we have put into the staging area and the snapshot has been taken internally. So the next step what we have to do is take this snapshot reference and create a commit ID. Okay, so how is that you're going to do? So let me clear the screen. So to do the commit now, we will use the command called git commit. Okay, and when you enter the git commit, whatever the changes that you have put into the staging area which has been taken as a snapshot, it will try to take that and the other details, that is the username and then the user email, and it will try to add the date and time, and it will try to store it as a commit ID. Okay, so one more thing that I was saying is, once again, the basics. If you are trying to do a commit, it requires 4 factors. One is snapshot, and then it requires the date and time, and then it requires who is the author on which is working, and then finally you will be giving the message on why you are doing this commit. That is another important factor that you're going to give. So when you are trying to run the commit, keep it as a mandatory practice where you will pass an option called -m and give a message on what is that you are doing and the purpose of it. So I'll say this is our first commit, so that later on I can understand. So what is that we have done? Now we have basically taken the changes from here and we have created a commit ID. Okay, so I have created some kind of commit ID. So now if I go back and see the status of the file, you can see that it is going to say there is nothing to commit and your working directory is clean, which means the files are in unmodified state. The reason behind that is whatever that you had now has already been stored into the repository and it has been tracked. So that is why the file has been called as untracked, or the status of the files in the workspace is called as untracked. Okay, now let's go this once again quickly and see the practice or the workflow. First, if you have a file, last time we created, now we already have a file. So what I'm going to do is, now quickly I'm going to put a line into this by modifying it. Okay, as of now this file is an empty file, right? So quickly I'll put a line inside it. Once again, this is just a Unix command where instead of printing something on the screen, I am redirecting it. So usually if you just say echo and something, it is going to print it on the screen. So what I am doing is I am trying to redirect this to this file. It's a quickly, a quick one-liner where rather than opening a file and adding a line, I'm just trying to put it. So now if you see, you will have a file 1.java which we already created, and inside that there is one line that we added new. Okay, so this time if you look at git status, it is going to say that the file has been modified. That is because git has been started tracking this file and we have the reference of this file already. So what is the reference that the repository has? It says that you have a file and it is an empty file. So that is when you did the change on top of this empty file by adding a line, it is saying that whatever content that I have in the repository is not the same what you have, which means you have done some change on top of it. So the git is considering that this file is modified. Okay, so once again, now once you have done the changes, what you will do, we will try to add it to the staging area. So you will say git add dot, and now if you run git status, you can see it is going to show it in a green color where it is not saying that it is going to be adding the changes, but you are ready to commit. That means the snapshot has been taken. Then how is that you're going to commit? You're going to type git commit and give a message which is mandatory. So we will say our second commit. Okay, so we have done the changes, and now if you do a git status, it is going to say everything is clean because whatever that you have modified, you have taken through the staging area, and we have done one more commit now. right? So because of the second commit, now we have the changes being tracked. So that is why it is going to call it as a unmodified, because whatever you have now, the content is there. So like this, no matter how many files you have, you are going to modify and Git is going to track it. Okay, so this is how you modify a file, you put into the staging area, and then you commit it. Okay. So to quickly understand that, what are the commands that we used? So the first thing is we used git init to create a repository of the type of the type bare or central. From this, if we wanted to create a local copy, I would say git clone, and I would give the name of the central repository, and then I would give the local workspace name. Correct? And then if you want to do the changes, you don't have to use any git command. It is all your operating system command. But if you want to put the changes into the repository, you will say, sorry, if you want to put the changes into the staging area, you will say git add. And then if you want to put the changes into the repository, you will give the commit message followed by a -m. And any point of time, if you want to know the status of the file, you will use git status. Okay. Now, we will use one more command called git log that will give us the list of commit IDs that we have in this workspace. Okay. So now if you look quickly, it is going to show you two commit IDs. That is, we have done the commit 2 times. And with respect to that, it should have created 240 long characters, which is going to give the reference of what we did and when it was done and who did it. Okay. So that is what you can see here. So now you can see that it is giving you 2 commit ID, where this is the first commit ID that we did, and corresponding to it, it is created a 40 characters, which is a unique one. And for that, who is the author that we created? What is his email? And then what is the date and timestamp on which it was committed? And then what is the message that you have given? Same way, the next commit ID, the recent one that we did, a unique 40 characters for that, the author, email, date and timestamp, and the message. So this is how for each ID or each commit that you're going to do, you're going to get a unique commit ID and it will be tracked. Okay. And now, let me quickly open one more git bash prompt and let us go to the central repository. Okay. So a commit ID is not with respect to a file. Okay. So that was the next thing that I was anyhow going to say. So a commit ID in Git is a collection of a file. So it is nothing related to one file. It is a collection of files. But if you want to look on what and all are the changes that has been done by this commit ID, then you will use a command called git show and give the commit ID, where you can give the complete 40 characters or you can give the first 7 characters. Okay. So now this way, it is going to give you the complete details on what exactly the snapshot of this commit ID refers to. So you can see that it is going to refer to a file called 1.java, where you have actually added a new line called line 1. So that is how it is going to say that you have added one line, and what is that line? Called line 1. Okay, so that is how you can get to know on what exactly you have modified for the change. And as we go on, every commit ID will not be pertaining to one file, but you can have a collection of files or a group or a set of changes, and you can store it as one commit ID. Okay. Coming back to this. So if I go to the Git repository, let me go to the central repository. And in this, if I type git log, you can see that it is going to give me a message saying that there are no commit IDs available. Why is it? So let us be more clear now. Where is that we have done the changes and all the commit has been stored? So all the commit IDs has been stored in this particular repository of the workspace. What is that workspace? This is the workspace. So as we know the basics, every workspace will have its own repository. And because of it, anything that you do to that repository will be stored and known only to that workspace. This is the very first basics that I was explaining you yesterday in this. So if you remember, I said, if you create a commit ID in a particular repository, only this will be knowing. In the same way, if you do a commit and store it in this workspace in Git, only this workspace knows about it. So now, like this, a user will continue doing the changes. Okay. So once the changes has been done, the next thing what you have to do is you have to share it with others, or we have the central repository. This is where you have to permanently store so that others can take your change and modify. So that is when now you have to take the changes from your workspace, that is the repository available under this workspace, and you should be putting everything as a copy back to the central repository or the workspace which is being used as a sharing for central purpose. Okay, so how is that you are going to do? So that is when you will use a command called git push. Push means you are going to push all the commit IDs, or simply in terms of Git, we are going to push all the references that is available only in your workspace, and that which is not available in the central workspace will be taken and shared. So that now, if you look here, you will be getting all the commit IDs that you had in your local workspace, which has been shared to the central repository. Okay, so that is how first you will do the changes in your local repository and keep continuing storing the changes, and whenever you feel that you have to share it with everyone, then you push it to the central repository so that now it is completely available for everyone else to use. Because when you go as an organization, there will be, let's say, 50 developers, and each developer has his own workspace. So if you are dependent on one particular file change, you don't know who is the workspace, who is the user working and what is the workspace on which he is working. So rather than that, you can always refer to the central repository. If those changes has been pushed into the central repository, you can always use this central repository and create your workspace. Okay, so that is the process. And going back to the first configuration on why did I use a configuration called push.default, it is because of this. Now, if you say git push, it automatically goes to the origin of this workspace. What do you mean by origin? Origin is nothing but the workspace or the central repository from which we created this. So I ran the git clone command with respect to this workspace, right? So when you do a git push, it is going to automatically go to the central repository, that is the origin of this, and push everything. That is why we give that push.default as a simple way. So I don't have to give the name. Automatically it will go to the central repository, which was the origin for creating this. Okay, so like this, every user will create his own workspace and he will try to push the changes to the central repository. So now, let's say a new user has to create his workspace. What he will do? So pretty much in his machine, okay, what he will do is he will once again do a git clone of the central repository, and he can give some new name for this. So what I'm going to do now is, in the same directory, I'm trying to create as if a new user is creating a new workspace. Okay, so this time I'm creating a new local workspace called new workspace 02, which is going to be a clone of central repository. But this time when we are cloning, we have already some content in the central repository, right? So everything is going to be available in our new workspace. So now a new user, whoever is creating the workspace, if he goes inside it, you can see that he's getting the complete content what you have in the central repository. So that is how, if a user is creating a workspace, he will be getting all the changes that he has in the central repository, and along with it, he will be getting the complete list of commit IDs also. Okay, so remember, this is how everyone will be creating their own workspaces and they will be doing the changes. Clear with it? So the last thing that we saw is, once you have done the changes, if you want to share it to the central repository so that others can take, you will do a git push.